Hello, Algebra 2, Period 3. We're going to go over our samples in preparation for our quiz on Lesson 8.4a. So we're going to do two samples, both with the same directions. The directions will be to graph the ellipse and include the vertices, covertices, and focus points. So we're going to list that information both in the graph as well as outside of the graph. So here we begin. Our equation that we will graph first is x squared over 100 plus y squared over 81 equals 1. We're going to recognize that as an equation of an ellipse. We're noticing that we have both x squared and y squared added together with denominators of 181. Those are going to be our a squared and b squared. And we're equal to 1. So we recognize this as an ellipse equation. And over here, here's my thinking bubble. You don't need to write this down, but we are thinking that x squared over a squared plus y squared over b squared is equal to 1. We're noticing the a squared is underneath the x squared because 100 is greater than 81. Remember, for our ellipses, the larger of these denominators is going to be assigned the a squared number. So I am writing down that a squared is 100. And I'm then taking the square root of both sides to arrive at a is 10. B squared is 81, that's this number here, that's our b squared term. And when I take the square root of 81, b is 9. So that's going to give me some important information about my vertices as well as my covertices. Next, I need to find out what is my focus value. So the relationship in an ellipse, if you'll recall, is c squared is equal to a squared minus b squared. So we'll plug those numbers in for a squared and b squared. We already know that's 181. We already wrote that down here. So c squared is 100 minus 81. That gives us c squared is equal to 19. Taking the square root of both sides gives us c is the square root of 19, which is approximately equal to 4.4. I'm using my calculator to find that value. Now I'm ready to start listing my vertices, covertices, and foci. I'm going to go ahead and write that down over here, and then I'm going to graph all that information in just a moment. Since my major axis on my ellipse is going to be on the x-axis, the larger number is underneath my x squared. That's how I know that my major axis will be the x-axis, the horizontal axis in this case. So I'm going to write the number that I got for A in my x-coordinate position because my vertices are on the horizontal axis. And then the y-coordinates, of course, will be 0. My foci, that's plural for focus again, will be also on the major axis. So I'm going to make sure that the numbers that I get for my c values, my foci, are also going to be in the x-coordinate position, and the zeros will be in my y-coordinate position. So over here you can see that I've graphed my vertices, 10, 0, and 10, negative 0, and of course my foci are also going to be on that same axis. The covertices will be on the opposite axis. They're going to be on the vertical axis, so that's why I know that my number 9 here for my b is going to go in the y-coordinate position. So my covertices then are 0, 9, and 0, negative 9. I graph all that, and this ellipse looks more like a circle than an ellipse perhaps because the vertices and covertices are so close in number. 10 and 9 aren't very far apart. So that's why this looks fairly circular. It's not as squashed as some ellipses are. The next one we'll see an ellipse that looks maybe perhaps more like an ellipse and less like a circle. Example 2, we're presented with 36x squared plus 9y squared equals 324. We're noticing we're not in standard form for an ellipse. This number isn't 1. So we need to go ahead and divide the entire equation by 324 so that we have 1, because our standard form of our ellipses will be equal to 1. And conveniently, of course, 36 and 9 do happen to go evenly into 324. So when we divide the entire equation by 324, we do arrive at the standard form of the ellipse equation, x squared over 9 plus y squared over 36 is equal to 1. So the 36 and the 324 cancel. 36 divided by 36 is 1. 324 divided by 36 is 9. And I know that because of the work I did over here. And then over here, the 9 and the 324 cancel. 9 divided by 9 is 1, and 324 divided by 9 is 36 again. I have that information over here, and 324 divided by 324 is 1. Okay, now I'm ready to decide which equation I need to use for my ellipse. Because my number under my y squared is the bigger number this time, I'm going to use the equation x squared over b squared plus y squared over a squared is equal to 1. So this time my a squared is under the y squared because it's the bigger of these two numbers. So here I'm working out my values for a, b, and c. A squared is 36, so A is 6. B squared is 9, so B is 3. To get from 36 to 6 and from 9 to 3, of course, I took the square root of both sides. Then I'm going to work out my C squared to figure out the value of C. C squared is equal to A squared minus B squared. Plug in my numbers for my A squared and my B squared. That's 36 minus 9. So this should always work out to be something positive, since we're always choosing the A squared to be the larger of the two numbers. When we subtract the larger minus the smaller, we should get a positive number here. If we get a negative, we're going to suspect that maybe something isn't quite right with our work yet, and we would want to go back and fix that. C squared then is 27 when I subtract that 36 minus 9, and C then would be the square root of 27, taking the square root of both sides, of course. And on my calculator, I see that the square root of 27 is approximately 5.2. Okay, now I'm ready to write my vertices, covertices, and focus points, and then to graph my ellipse. So this time, my vertices and covertices are quite different numbers, and so it looks more ellipse-like when we actually graph it. Again, ellipses can look almost circular if the vertices and covertices have numbers that are fairly similar. I know that my vertices are going to be at 0, 6, 0, negative 6 because my A squared was underneath my y squared. So that means that my major axis is the vertical axis this time. That's why my y coordinates have the non-zero number. Of course, my focus points will also lie on that major axis, so I know that my C number, 5.2, will go in the y coordinate position so that it matches the vertices 0 in the x coordinate, the other number in the y coordinate. Covertices. So my covertices lie on the horizontal axis, so that means that I'm going to have 0 in the y coordinates for my covertices, 3, 0, and negative 3, 0. And then I just graph all those points, and as best I can, I draw an ellipse through those points. If it's a little wobbly, we're okay. It can be a little tricky to make it nice and smooth, but do the best you can on that so it looks ellipse-like. Make sure that you do label all of your points so that you can see how those points actually fall and relate to the ellipse equation. All right, so let's make sure that you are taking notes on these samples, reviewing that in preparation for today's quiz, and I'll see you next in the guided practice problems.